So before we start, I would like to give you the overall pictures. How can we design the machine in the real productions? So this flow is can tell you how we start and finally what customer require from the design team. So I will start from the machine design process. So let's separate to 3 boxes. So the machine design process start with the first box, the pink one, starting with the customer. So in this case, I mean the internal customer. Most of them is process or manufacturers part who require design team to build the machines based on specific manufacturing requirement. And for each project, there usually has the project lead responsible to coordinating the projects and work with team from the different departments. So in CAD itself, so the requirements for the machine design are divided into 3 parts. Let's start from the first one, machine functions. This defines what the machine needs to solve of the customer problem. So for example, the machine might need the pick and place functions, require conveyor to move materials, and that they has the target machine can build the unit per hour up to 600. So this is the initial thing that they want as a guide to design process. So the second one, the functionality about the safety thing. So we are focusing on the safety standard. So we follow our intent safety standard. It's called SOP 39. It's or safety operation procedures. So it is adapt for the global safety standard like semi or enzyme to fit to CAD context. So and safety qualification. So we use the internal safety qualification is called STEP or simplified to evaluations protocol. It with recognized machines by their list labels. So it's often low list for internal design. So and last one is the material and ESD qualifications. So we ensure that the machine design and material prevent contaminations and electrostatic discharge, or we call ESD, which cause the product qualities. So because in CAD we work in the clean room environment, electric design control help to minimize this leak. Okay. And move to the medium one, the design team. Machine design requires the collaborate between 3 engineering teams. So the first one, mechanical engineer, responsible for the machine flow design, machine structure, robot working area, or pneumatic components. The second one, electrical engineer, handles the component selection, electrical safety design, circuit design, and control system. So electrical engineer also act as a mediators, helping align the mechanical and software system to complete the machine indications. So and last one is software engineer. So they develop the program for system control, algorithm, and software maintenance. All 3 teams must work in the same directions, follow the design instructions, and the system qualification guidelines. Okay. And last one, about the machine qualifications. Once the design is complete, the machine go through the qualifications process involves multiple checks. The first one, internal customer does require or make the machine right, they will come up with the checklist, or the machine have to like meet the requirement in terms of functionalities, UPH, yield, and downtime, and other performance goal outline. That's we talk in the scope of work. And the second guy is the ESD and contamination audit. So in CKSL, we like dedicate the audit team equipped to specialized tools to detect the checklist. Every machine must pass all of these tests. It may be 100 items to ensure there is no leaks of the contamination or ESD before machine can use in the productions. So, and last team is the safety qualifications. This is the most important part of the qualification process. So that's require both internal safety team and third-party safety inspectors. So because of this one is direct concern to human safety. So we invest over 30% of the total machine cost for the safety. Okay. That's today I will focus on the safety design concern and show you the real production example. Okay, and next, I would give you the overall the business flow when we start to design until it release to the productions. So the business flow that design team use for the standard procedures for the machine design. So we have start from the get requirement from our customers. I mean internal customer, and then we like create the QFD or quality of deployment on kind of map to convert the customer point of view to the engineering requirement. So and next we develop the scope of work with customer together. Then plan to the budget to support overall projects. An example, the assembly cross equipment, robot, pneumatic, SOP 390, so sorry, SOP 39, qualification, cost, and so on. And then we create the initial timeline for team reference. But this timeline still need to review with whole team again to match with the customer timeline. So then go to this box, the conceptual design. Normally, design team will come up with 3 concepts. That is maybe an image or initial process concept for team considers. And then we use the KT analysis to select the best one to use in the design. For the KT tool is the like a tool to select the best way. Initial we do like we not use just only one part. We should have like a backup or another way to select. But how can we know which one is the best? We use the KT to select it. Okay. And next go to the design phase. 3 engineers I mentioned earlier works on their design and the criteria, then create the FMEA, the failure mode analysis to analyze to prevent the design go wrong by whole team to cross the problem on the machine. So sometimes it require all customer to review as well. So we also have the internal peer review here to review in each step. If it don't pass from the peer review, it will go to the design team again, go to as a loop After it's passing this process, it go to the purchase process. And in part of the vendor fabrication, it also has the part inspection and test again to ensure this part will go collect. I mean, the small part, in every part, it will be inspect and qualified by purchasing a team again. And after pass, it will go to the small part to indicate the machines and test the machines. After we indicate that for whole machines, it will check, it will has the process to check it, this assembly has issue or not. And the last process is the evaluation. It means the functional test. It requires 100% test. Is maybe 1,000 items to evaluate. Does it need 100% to qualify before release to the productions? In the parallel time, we have to like complete in terms of the document as well to use for the maintain the design in the system. This one is the overall how we start to design and which plan we will go for overall design. And so today topic, I will talk about the safety standard SOP 39. Let's dive into the detailed topics. So normally the full SOP 39 trainings take about 5 days to cover 20 topics. But today we will focus just only 3 key areas that cover the basic safety knowledge we all should know. So in the real SOP 39 qualifications, most of the details are related to the electrical powers and safety. I would say over 70% related to electrical thing. So today for the lesson, it will be electrical part, EMO interlock, and the mechanical robotic. Okay. Let's start for the overview and EMO. Before go to the design, let's know some wording related to the safety thing. The first one is the critical component. What is the critical component? So if you select the part to use, right? First of all, you should know about its specification in terms of voltage, current, and power consumption. Let's consider at the voltage first. If the voltage is higher than 30 volt AC RMS or to 42.4 or 60 volt DC, this one is considered to be the critical component voltage. And if it has the power, use the power over 240 watt, it's also considered to be the critical component. In this voltage, if it over this values, it can shock to the people. That is may cause of electrical shock. And if the power is higher than this one, is higher than 240, it's gonna start to the burn. Is the cause of the fire. Okay. This is the direct impact for both personal safety and production safety. In terms of safety itself, is gonna make more problem for the tool damage, and we will lose the productions. We cannot build anything. In terms of production, in normal process, we use every time of the machine. Normally, machine run 24/7. In 1 year, just only around, as I remember, around 6 hours machine stop for maintenance, and that's all run 24/7. Okay. Another is the safety protective device. This part is talk about every part that's used for the safety. This all require the part should be certified by NRTL or National Recognition Recognized Test Laboratory. And let's see what it is. So two type of laboratory ensuring component safety. So when we select the component or equipment for the productions, so two type of laboratory ensure they meet the high safety standard and are the safe to use in your workplace. The first one is accredited test laboratory. This lab evaluate the product based on the safety standard. They demonstrate the technical expertise and ensure the competence for the lab performance evaluations. They focus on verifying the technical safety as a component level. And the second one, NRTL are specific recognized by, so we call OSHA, Occupational Safety and Health Administration. Is like a กระทรวงแรงงาน in Thailand. It's for workplace safety in US. These labs are authorized by OSHA to list the label products that meet the safety standard, ensuring they safe for use in US. In CAD Thailand, we also apply this standard as well. And NRTL focus on the certifying the products of safe for workplace use under OSHA guide. So what is this one? What we can see. So we call another name is we call the safety label. So you can see at your products. Let's see, for example. So this is the safety component, right? This is the EMO. If you open in your data sheet, you can see the safety test mark. And when you see, right, you have to back to like a check. It has the in list of NTRL or not. This one is, for example, we have like a TUV, UL. That is mean this part is, it has been qualified by third parties. We ensure that it can use in all productions. Okay. And this another example, this is the power supply. So if you see the data sheet, it will tell you the specifications of this power supply, and you can find the certification like this in the red box. This one passed the UL number 408, and it's also passed the CSA to qualify the safety test mark. Okay. This is a kind of the critical component. Look at the power consumption. The input is the voltage is higher than the critical component limit, right? It has been defined to the critical component as well. So other thing is the contactor relay. So the first thing we should consider is they are the safety test mark or not. Any questions so far? So and next, I will talk about the concept design for the SOP 39. So in safety designs, we incorporate the redundancy system to ensure both human and machines protections. So you can see the left-hand side from this slide. The machine is designed to perform its core function. It's included computer unit here. It's which may be the computer controller or PLC based. That depends on the design system. So in addition, it consists of the monitor to control and device of the controller here, the I/O modules, and other electrical components for the system control. This is construct as a standard control system. But look at the right hand side, you can see the safety PLC. It connects to the computers for monitoring. And you can see the hardwire safety. Hardwire is mean is require the real wiring to direct command to each sensor. So this one is connected to the safety protective device such as the interlock, the emergency or EMO, light curtain here, and send out the output to the contactor relay. The purpose of this safety is continuous monitor and protect human and equipment. So to enhance the machine safety. So as I mentioned earlier, we allocate and additional 30% for the machine cost to implement this safety to monitors as a real time. So and next topic, I will talk about the key concept to stop machine when an accident occurs require a multiple layer approach. So it's combining engineering safety features with the proper trainings and procedure. So let's see the breakdown how to stop the machine, such a situation. So when you are in front of the machine in the production, you may see several operation panels, and common feature is the LED mushroom style button with the yellow card like this, or sometimes just the LED button. So there are the EMO, or we call emergency machines off, and E-stop or emergency machine stop button, both critical for the safety. So let's see how it different. Let's talk about the EMO first. The EMO is emergency machine off. This is the function, not just the single button. Okay, it shut down the entire machines or the process, either during an emergency or as a part of planned safety procedures. For example, when would like to do the maintenance, right? We would like to shut down machine. Normally they will push the EMO to cut off the power. The goal is to prevent situations from getting worse. It typically used in more controlled and planned emergency scenario. And move to next is the E-stop or emergency stop. This is the big red button in normal. It's for immediately actions, and it designed to stop the machine quickly to protect people in case of emergency. It's positions where anyone nearby can easily reach into stop the machine to avoid dangers. So in the real ones, in the production, operators don't, when it had accident in the machine, for example, operator like not select which one is EMO or which one is E-stop. They push it first. If they see the late one, they push to stop machine first. But I would tell you is the functionality is different. When we talk about the EMO, right, it will cut off the power. I mean entire power in the downstream. But if we're talking about the E-stop, it's just only part of the machine. I will give you more example in the schematic again. So, and in addition, so we also have the like a machine stop. This is the just only the function for the machine is refer to the stop the machine in the control manner. Okay, is not emergency or stop the machine. It's normal part of the machine operations. Like when the production is finished, the operator need to like safety stop machine. Usually it control, for example, it control the deceleration of robot. You will like a command direct to the controller to stop the machine. Any question? So this one is the summary tables. The key difference of the EMO and E-stop are the critical safety function designed to like a disconnect power and immediate stop the machine. This function require direct hardware connect to ensure rapid shutdown emergency situations. And for the machine stop, on the other hand, so it is non-emergency control stop typical initially via the software, allowing for the safe orderly for the machine operations as the part of the normal process. Okay, and next let's consider when we like indicate the machine together in the live system. So when the machine is integrated into the compressed system, so the emergency stop button must be installed every 12 meters along the operation working areas. So if any EMO button is pressed, the power to downstream machine will automatically cut off. This is the critical safety feature that help prevent accident and protect other worker operating in this area. So for example, if the part is the part 4 go from the top to this line, right? If someone put this EMO, the downstream machine will be cut off the power to protect the human working in the same area. So another important safety term to know when working with the machines. So especially when recovering the machine after the EMO switch is pushed. So when you like someone put the EMO, right? That is mean it has some accident in the machines. And there are technicians would like to fix that problem. This is the procedure to go to access in the machine. So is the lockout tag out, or we call lotto or lotto. Yeah. It is a safety procedure designed to the protect worker from dangers of the unexpected machine startup or energy release during the maintenance or service. Let's see, it consists of two words, right? Lockout and tag out. The lockout is mean physical shutting off the machine energy source, like a electrical. So if we're talking about like the power source, it not only the electrical thing, it's maybe hydraulic, pneumatic powers, and it locked to off position using the special tool lock you can see in this picture, right? When the EMO is pushed, right, it has the small hole like this. You can use the lockout tag out here to cross this one. So in normally process, we will have the supervisor is control the machine first. They will use their own lock to lock first, and then the worker will use this logout tag out to cross it again and use themselves key to cross it to ensure if there are anyone working on the machine, if there are someone would like to open the machine, it cannot do it because of it cannot go to like recover the machine again. So the for and log out, after we locking it, right, the warning tag is attached to the log process. This we can know who's working on that one. Okay, following a logout trackout for procedure is help keeping everyone safe. So, and next, let's look at the difference between EMO and e-stop in terms of electrical circuit. So this slide show the AC line diagram that demonstrate the safety functions process. So we starting from the incoming power. So let's imagine this is the home power 220-volt single phase. And for simplifying the diagram, it had just only the AC line and the neutral to return back. Okay, it not include the AC ground. So let's see how the system work. So from incoming, we have the disconnect switch first. The incoming voltage go through this connect switch. This switch control all incoming power, and it can use the lockout tag out. You can see the small hole here. It's just during the machine maintenance. And next, go to the circuit breaker and ELCB. The power go through this main circuit and ELCB, which protect the system from overload and leakage current. So we use a different purpose for the main circuit breaker is used to protect the machine, and ELCB is used for protect the human. Let me go to detail again in the slide to tell you how does work. So and then the power go to the power the main power supply. The AC power is converted to DC to the power supply safety DC circuit and the DC component. At this point, you will see the contactor relay. This work in the redundancy concept. It used for the power control. Okay, and this one is split to two sections. So the first one is the control power. Is controlled by the EMO switch. And other is drive power. This one is controlled by e-stop signal. So let's compare to how the human body works. So let's consider at drive powers. When the drive power is interrupted by the e-stop functions, it's like a muscle cannot move, but the brain still working. The system can still remember its position and calculation. So to restart, the operator just push the start switch again, and the machine can continuously run because of it can remember everything like encoders or some position that we need to park before the machine open. And when we talk about the control power in this loop, right? If it interrupted by the EMO switch here, it's like a brain and muscle both shut down. All the power is gone. The system lost its memory positions and any going calculations to cope To like a recovery from this, you will need to technician or engineer to troubleshoot or restart the system. This comparison help show why these two safety functions are so important and why they affect the machine recovery in different way. So this is the example how to select the motor control for the recovery functions. So when you select the motor controller for the production range, it's crucial to consider how the electrical power is supplied to the controller. The power should be separate to two parts, the controller part and drive part. Let's say in this example, you see the yellow one, L1 controller, L1C and L2C here. It represents the control power. And L1 to L3 represent to drive powers. So by using this magnetic control and or we call the contactors, managing the powers becomes simpler and more efficient. If controller power is not separate from the incoming powers, so the machine will lose the position memory. So in this case, a recovery process will be needed, which typically involves the maybe homing the actuators or recovering the last position, the machine back to its starting position. The process may take up to 20 minutes, but if we use the separate the powers controller between controller and drive, we can do the quick recoveries. It may be down to 3 minutes to recover, because it's if like we cut only some part when we open the door, right? Just only the drive one. It means muscle is stopped, but the brain is can remembers. So any questions so far? Okay, and next I will uh go to the detail of the EMO circuit. Let's say this diagram is, so we call the line diagram. So let's start from the incoming powers. This one is the safety circuit, right? So we use the small voltage to handle on it. So this one use 24 volt DC come to the start switch. Okay, this is the start switch. Is the type of start switch is press to turn on and release to turn off. It just like a single shot working. And then there are the normally open from the relay one parallel on this loop. And then go to the EMO switch. The function of EMO is press to latch switch. That means this one need to release before turn to the normally process. And it will direct to control the relay one call. And we have to the writing act as the hardware for to show the EMO status and interrupt status here. And in this loop, we have the interlock switch. Its function work as a press to turn on and release to turn off switch. It will connect direct to relay to coil here. And we also use the normally open of the relay to control the interlock status like this. So let's see the conditions when we push the light current. So sorry, when we push the EMO. So we have 3 buttons, right? The first one when VMO is closed circuit at a point, and the start button is open circuit. That means we don't push anything in the start button, and in the lock switch is closed circuit. Let's say just only relay 2 is active, right? But there are no any writing is turned on because of the circuit as not close to the loop. This is the normal process before we start the machine. And the second condition when we start to push the start button, this one, right? It has the single shot or the pulse signal to start to turn the relay 1 coil close to closed loop circuit, right? It's turned on this one. This one is turn from the relay 1 normally open to normally closed. This loop link together, okay? And it turn on the writing here. And look at this loop, the relay 1 pin number 40T and number 44, it linked together. It turned from normally open to normally closed. And the relay 2 contactor here has been controlled by the relay 2 to close the circuit. That is turned on the writing tool as well. Okay, this is the starting process. The circuit will be latched by using this contactor relay 1. And the third condition, okay, so when someone open the door, that means the interlock open circuit, right? The relay 2 coil will turn off, and then this contact relay will be open circuit. The result turn the writing number 2. This one should be turned off. Okay. So this condition is we talk about when we open the door, the interlock switch is open circuit. Just only the writing number 2 is turned off. It represents to the drive level is turned off. So, and last conditions, when someone push at the EMO button, right? The contactor relay from the coil 1 will be turned to open circuit. That's all writings turn to off position. Any question? So this is the simple circuit, but it's crucial for design, and you can use this one for your design machine when you start to do like the schematic. Let's consider this one first. You should have at least one the EMO button to control the power sourcing to your circuit. So, and next, let's move to the safety protection component. cable standard interlock and machine grounding. So let's start from the protective device here. So the questions why a protective device required for the system. So let's dive into the main cause of leaks electrical system is the overcurrent. So when we talking about the overcurrent, what it is? So the overcurrent happens when too much electricity flow through the wire more than the design that can handle. Let's imagine the water flow through the pipe. If too much water is forced through the pipes can burst. Similarly, when too much electricity flow through wire, they are start the overheat, melt, and even fires. So there are two main causes of the overcurrent. The first one on the left hand side, you can see the short circuit. It's like a electrical contours. It's happen when there is the problem in wirings. So you can see the red one. So it's often during the damage for like an insulator. In the normal for the current for the right path to the load, right? From the line in the back one and return to the neutral. It bypassed to the red color here. There is the very little resistance here. It can become massive, and this surge can quickly overheat wire, melt insulations, and even start a fire. And the second one is overload. Overload occur when too much power is drawn from the circuit, more than it can the safety provide. This often happens when you like plug too many high power device into the same outlet. It's just like the short circuit. The overloading cause wide overheat and can lead to dangerous sequentially and got the fire. And next, let's talk about the circuit breakers. So the circuit breaker is the key device that protect uh the circuit. Okay. So we will look at how they work and different type, and they are so important for the radical safety. A circuit breaker is actually like a switch that's automatic turn off when it's detect much of current flow in the circuit. It helps to prevent the overheatings and reduce the leaks of fires. And next, let's see the main component of circuit breakers. Its basic function is interrupt current flow after fault is detected in two conditions. The first one when short circuit occurs, you see number one, the magnetic field generated by high current overcome to react spin allowed here. It will release the pusher to operate the mechanism, and the switch will be trip circuit. The white one is the operating mechanism. So if the overcurrent occur, right, this electric field will push this one open circuit. And the second one is when overload occur, the bimetal sheath deform is caused by current flow that hit the bimetal to open circuit. So you can see in the graphic, the current higher than limit at 10 ampere here at the right hand side. The bimetal sheath will deform and the open circuit at the end. It does mean one circuit breaker can handle both situations from the short circuit or over current. So when select the right circuit breakers for your need, it's important to understand the like a key specification to ensure we select the best one and the right one. Okay, let's start from the voltage ratings. The voltage rating, when we select the circuit breaker, right, we look at the maximum voltage that it can handle. And if the voltage rating is too low, the breakers may fault or to work properly. Okay. In the common, we use the voltage at 120/240 volts as a residential value. And we use 277/480 volts for three-phase or commercial industry. And the second one is the current rating. So this one have to calculate based on the design. Okay. And third one is interrupting rating. It talk about the maximum current that the breaker can safely stop during the short circuit. Okay. Normally its unit is kiloampere. It's talk about when we have like a surge voltage or flash current coming to the circuit at the starting time, right? It normally it shoot up to 1k ampere like that. The circuit breaker it should not trip at the short time. This one we have to consider as well. And fourth one is the number of pole. This depends on the circuit you use, single phase or you use three phase. If you use the single phase, one pole or two pole is considered to use in your schematic. But you use three phase, three pole or four pole is considered to use in the design. So and last one is the type of trip mechanism. As I show you, some circuit breaker it has just only the bimetal. Some circuit breaker it has a like a thermal thing, but some circuit it has both of them. That's depend on you select to use in your design. Okay, let's see in the real one in the data sheet. The first thing you should looking for the test mark it has or not. This one is pass the UL number 1077 and it also has the CSA approval. It does mean it has specific laboratory helping to like qualify it by testing in the lab. And next, let's see the maximum voltage. This is can handle both single phase and three phase here. And the current rating, there are several specifications to select to use. That depend on your design and your applications. I will go through detail again how to select this one. Okay. So any question? And next go to another type of circuit breaker. So we call the early gate current. Sorry, the early gate circuit breaker or ELCB is also known in names of residual current device. This is the safety device designed to protect against electrical shock. So we talk about the leakage current. This one is considered in the area that it had the waters. So it detects small stray voltage on the metal part of the electrical equipment and automatically cut the powers if the voltage reach the dangerous level. Let's see how that's the way next page. So the ELCB used 3 coil here, the red one, black one, and the yellow one sequentially. Start from the red one is we call the phase coil, and the black one is the neutral coil, and last one is the residual current coil. So let's consider at the first condition under normal condition. So the same current is mean the phase coil and neutral coil here. The current in both coil create the opposite magnetic fields. That means normal current go from the line here to the load and then return back to the neutral. It means there is no current in the residual coil. Look at these equations. If in the false leakage, for example, if someone touch in the line and go to another way like this, pass to the human body like this, go to ground, right? That is build unbalanced current from here. This unbalance is can control this relay to open circuit. The current trigger the tip coil of the circuit breaker, causing it turn off the power to prevent the potential arms here. This action help to detect electrical shocks or fire caused by leakage current. So when selecting and a leakage current in the circuit, there are the very important parameters to consider. The first one is the lead current. It depends on your circuit design, and the maximum current will carry. And the second one is the maximum voltage ratings. The maximum lead should be higher than the voltage used in your system. For example, in the single phase in the home power, right, the rating should be higher than 220. If we use in home, this 2 pole 240 is enough to use in your schematic. And last one is the lead residual operation current. This defines the maximum leakage current the system allow for the ELCB trip. Typical, this is set 10 to 30 milliamps to ensure safety operations. So what it means, if we select the small value like a 10 milliampere, right? If it has the small residual current, it will trip, it's safer. But the problem is it will like a currency trip. You should select the best one for your application. Any question so far? So and next I will talk about the contactor relay. I think most of you familiar with the normal relay, right? So let's see how it difference between the normal relay and contactors. Is two essential electrode mechanical switch device. But in terms of the principle how it's work, you can see it's work at the same way with the normal relay work. They are designed for different applications and capacity of the powers. Let's see the relay first. The relay are theoretical the control switch mainly used for the low power circuit and small load. They typically act as a control logic element, handle the signal switching or function interface between circuit with different voltage. The relay are smaller, have the lower current carrying capacitors compared to contactors. Let's see the contactors. It has designed to control the high power circuit and the large electrical load. Contactors are built with the strong construction and the large contact to the handle higher current. You can see in the picture, this is the example of the contactor relay. There are many contactors to handle for the high workload, and there are the normally closed and normally open for the system monitoring and feedback. You can see the pictures. The example they use is to control direct motor drive here. Let's take closer at the key difference in this table. The first, the significant difference in the load capacity relay can handle like a milliamp to the femtoamps. The contactor are capable for the managing 10 to 1000 of the amp. And the difference is the current capacity determine their specific applications. So, and relay is ideal for the control circuit and small load. The contactor are designed for the power switching and large equipment. So if we consider in terms of size and construction, the relay are small and less robust, make them suitable for the lighter duties applications. The contactor are built to handle heavy duties use. Okay, it's bigger. And in terms of cost, the relay are generally more affordable than contactors. Okay, and relay can handle the high switching frequency, but for the contactor, it's typical used for the lower frequency, like used to turn on and off the high powers. So and last one, if we consider in terms of the mounting options, the relay are often mounted on the PCB or DLL, and the contactors are usually for the panel mounts. This is the what difference between relay and contactor. So let's recap again. How does it work? So let's see in the picture B here, when the coil is not energized, the contacts stay in their normal position, which can either be open or closed depending on the design of the relay. So I'm talking about the normally closed or normally open. And look at the figure is when you apply the voltage to the coil here, the current start flow through is create the magnetic field. This magnetic fields attach the movable armature here to link the contacts. As a armature move, it change the state of the contacts. If the contact were closed, they will open, or if they were opened, they will close. Once the coil is energized and contacts are moved, they will stay in the new positions until coil is de-energized again. And you can see the number of the difference of the contactors between the normal relay and the contactor here. So, and key parameter to consider when select the contactor relay. The first one is the number of contact. So this refer to how many contacts as a contactor has. For a basic emergency machine off or the EMO circuit, your typical use 3 poles, but it can go up to 6 poles for configurations. When the normally open contact are used as the power control, and normally closed contacts are used for the monitoring. Okay, and the second one is the control circuit LED. This value refer to the voltage of the coil that control the contactor relays. For example, the DC power normally we use 24 volt DC as a common use in the DC circuit. Okay. And next is the LED current. This is the current LED that the contactor relay is designed to handle. It depends on your specific design and the load that you will be controlled. Okay.
ไอเดียเองหมดเลย
Any question? Sorry, any question?
ดูครับแบบก็เป็นอย่างนั้นเมาส์เขามันมีแบบว่าปกติมีสโคล่างสโคบนใช่ไหมเมาส์เขาสโคซ้ายสโคขวาได้ฮัลโหลเห็นไหมพลังแห่งเดินป่า
Okay, let's continue. And next is we talk about the voltage rating. This is the maximum voltage that the contactor can handle. For the single phase system, as I mentioned earlier, the voltage rating should be higher than 220 volt. Okay, and last one is the test mark. Yeah, we looking at the test mark in every part that we consider to be the critical component. So, and next is the safety relay. So the safety relay are special device designed to meet the strict safety standard. They are essential in the modern automate system, and they're built to protect both people and machines. The key features of the safety relay is the first one, they have the redundancy contract. You can see in the schematic here, you see in of this one is it has the redundancy contactor, right? It's meaning if one set fault, other can take over. So for example, if this pin is melt or a closed circuit all the time, this circuit the other one can perform to be the open circuit. Okay. And the second is force guide contacts to prevent dangerous situation by ensuring that is the one contact fail, other cannot cross. Okay. And the final are the self monitoring. You can see it has two contactors, two monitors. The contactor is open or not. Look at the K1 monitoring and K2 monitoring. It had itself the monitoring and feedback to your circuit. Is it properly work or not? This is the special relay. You can use the normal relay to perform this function as well. But the difference is you may use you require the last area to install it. If you use the safety relay, it requires small area to install in the machine. But the cost is so expensive. It's higher than the normal relays. I think almost 10 times. Yeah. So, and next I will talk about the wire color standard. Okay. So the question is, why do we need the standard of the cable wiring? The most important lesson is the safety. Let's imagine if every electrician use their own color, right? It would be confused. It's a lot of color, it's a lot of white in the system. So standardized color and marks help to prevent accident contact with live wire, which reduce the risks of electrical shocks and fires. Another benefit is consistency. For the standard practice, ensure the cables are manufacturers and installed the same way, no matter who does the work or where it's done. For example, when the machine design in US, if we use the different standard in Thai, that is mean we may need time to convert. We have to spend more money to convert from the US style to Thai style, something like that. So the standard that we use is the IEC. It is also set the minimum quality requirements for the cables to ensure they meet the certain performance benchmarks. And when something go wrong, the troubleshootings become much easier. Know the color code, help quickly trace the circuit and define the problems. Okay. And next, let's see what kind of color we have. As I mentioned earlier, one of the most recognized aspect of the cable standard is color coding. The IEC standard provide clear system for the identifies conductors. Let's say the AC circuit, the live wire, or we call the line cables that carry the current are usual is brown, black, or gray. The specific color depend on what you use is single phase or three phase. If you use the single phase, it should be just only brown color for the line. Okay. And for the neutral is used to return the current is always blue. And for the ground white, normally we use the green strip yellow like this. At the right hand side, we talking about the DC wine. Is you can determine the wine standard to use in your organize. For EasyGate, we have two DC bus in system. We have 48 4 DC for the power control, and we have 24 DC for the sensor safety and control the device. And we have like a standard in all organisms to use to control this colors group. So, and for the color coding is helpful to as a visual tool, but it is not the whole picture. IEC standard also require the cable to have the clarify markings. Okay, like manufacturing names, cable type, sizing, voltage ratings, or other specifications. So this might ensure traceability and help identify the cable characteristic. So another using cable and track. I mean the label like the white one here to give more detail about the circuit or purpose of the cables, especially in the complex installations. So let's imagine if you don't have like a label on the single wire, right? If you use the same colors, you will confuse for sure. Some machines may has over thousands cable in the system. If you don't separate the cable colors, you don't have the label, you cannot work in the machine for sure. And next, other thing that we have to consider is to the how to select the cable or wire sizings. Do you know about the AWG wordings? In Thailand, we may talk about the diameters of the cable, but in US company, we're talking about the AWG. It is the American wide gauge standard. Okay, it is the standardized system using mainly in North America to specify the size and thickness of vertical wire. So the key idea is the relationship between AWG number and wire thickness is invert. You can see in the picture here. A smaller AWG number is mean thicker wiring. Here you see here, and the larger AWG numbers as a 40 here is mean the thinner wire. It's matter because the size of wiring affects its ability, safety, current carries, and how much electrical resistance it has. So let's consider these equations. R is low L multiplying, divide by L. I don't see it. Again, R is low L divided by area, right? So thicker Y give the bigger cross-section area with let them carry more current with less resistance. On the other hand, thinner wide or small area which can carry less current than a higher resistance. Think of it like a highway. A wider highway can handle small traffic flow. Okay, and in this equation, let's consider the resistance coefficient as a constant values. That is depend on the a kind of material that we use. Sometimes we use like a copper is had one coefficient, and if we use aluminum it should have another kind of coefficients. Okay. And next I will talk about the American market. How can we select it? One of the most important factors when choosing the wine is we use to like open this table, we call it amperity tables. With it, the maximum amount of the current that can safely carry without overheating. The several things determine the wide opacity include the sign material. It's like a copper, aluminum, the type of insulation, and the temperature allow it. The AGV chart gives you the opacity ratings for the different conditions, helping you pick the right one that can handle the intense current load setting without leaks or fires. And this slide shows the opacity table follow the semi number S22 standard. When we design the safety component, we use this table to select the safety system. Okay. Let me give you the example again in the design page. Okay. And next, the cable type. So for the electrical cables come in different type. Each type is used for the specific use. For example, the residential wide. So we use the non-metric cables as a common. Okay. Another example is the coaxial cable is used for the transmission high frequency signals. And twist pair cable is the main type is used in the data networks. These are just the example. It is important to choose the right cable for each job. When you design, you have to consider in every single part that you design and matching to what kind of the cable that is matching to your application again. So, and next I will talking about the grounding system. What the grounding system? So the grounder system is the one where at least one conductor, let's think about one conductor is connected to the ground. Okay. The purpose of the grounding is to control the voltage to earth, keeping it within predictable limit. Okay. It's also ensure the flow of the current does follow detections of an unwanted connector between the system connector to ground. Also known, normally we call the ground fault. For example, look at the figure A first. So show an ungrounded equipment frame. Okay. And let's think about when the ground fault conditions. If fault current flow through the equipment frame and someone push at the frame, right? The human body is will be the ground path to to the to the earth like this. This situation can cause observed shock and could even be like a human die. Okay. Let's think about the key idea here. The ground fault current always try to follow the path it least impedance. That means normally it can go to this way, right? But this machine it has insulators. The resistance of the human is less than insulator. The current least go to the human body to ground to earth. That means that is the cause of the shock. Okay. Let's say in the picture B, the same ground fault scenario, but with grounded equipment frame. The frame is go to ground, right? Here the fault current flow through the equipment grounding conductor safely direct to into the ground. Okay, that is the concept. In every the moving part, for example, the door. also should have the grounding system as well. So in normal process, we have two kinds of ground in the productions. The first one, this safety gown that we are talking about. And other we call the ESD gown. The purpose of ESD gown is to protect the ESD in the system. That is used for protect any equipment or part. Okay. In practical grounding in the real machine, so this slide demonstrates the practical applications of the ground in the real machine. So the grounding system is the component of two main ground points. The first one, let's consider in the picture on the left hand side. At the incoming start here, this is where the ground system connect from the facilities or the coming source. It is the starting point for the ground setup, okay? And the second one is distribution start. This point is responsible for distributing the guided wiring to the equipment and machine frame. It ensures that all parts of the machine are properly guarded. Okay. And on the right hand side, you can see the assembly sequence for the ground connections. The process for following this step. We go with the star washer first, and next go to the connector wire to the equipment, and go with the star washer again, and finally it will have nut. This step-by-step guarded methods following the safety standard SEMI S24 to ensure the system is safe. Okay. Any questions so far? Okay, and next one is the interlock. So today in the lock switch, that I will talk about is common example in the productions. So the interlock switch is the safety device that stop the machines from running when something unsafe is detected. Their main job is to protect workers from dangers like a moving part or pitch point. These switches are built into the machine control system. So when something dangerous happens, like sometime open door or panel, the interlock switch send the signal to stop the machine to prevent from machine starting. This quick action keep workers safe to make sure the machine cannot run when there's leak. So, and today let's look at I will talk about three common type of interlock switch used in the productions. We talk about the light current, safety switch, and two-hand control. Okay, let's start at the light curtain. Let's see how that's work. Let's see at the picture A. The light curtain used an array of invisible infrared light beam. These beam are projects from the transmitter left hand side to the receivers or RX, create the protective fields. If something interrupt in this field, for example, someone push hand to that area, it sends signal to stop the machine. And let's see the operation mode in the figure B here. It can separate to two modes. The first one we call the trip mode. If someone interrupt in the light field here, the machine pause. Once the obstacle is gone, the machine resume automatically. Okay. And the other mode is we call the latch mode. If the light curtain field is interrupt, the machine stop. It's required a manual reset to start again. This mode is used for the safety purpose. Let's think about if there are any accident in the machine, right? Or someone go to the detection area. That is mean something wrong in the system. If it can go to trip mode, it can like a automatic recovers. It does mean the problem still not solved. In safety term, we need someone like a technician or engineering to take a look what's happened in the machine and to ensure the machine don't have anything, don't have any problem. They can resume it again by reset the system. And next, for the resolution of the light current, see, please see in the figure C, the resolution refer to the space between the sensor in light current. If high resolution is used to detect the small object like fingers, in the resolution considered to detect the hand. And last one is the low resolution. It detects the larger objects like an arm or person. When choosing the light curtains, pick the ones based on your specification needs. Okay. So and next I will dip to the machine design. So the effectiveness of the protection and light current positionings. So the light curtain should be pressed at the safe distance away from the dangerous zone. So we call S in this equation is the minimum safety distance. This distance ensures that if something enters to the light curtain field, the machine will stop before to reach the hazard area. Let's see this equation. S is K times T. S is, let's see K. K is the constant that depend on the machine speed and type. Look at the K values. If the distance less than 500 millimeters per second, consider to be, sorry, let K at the first one. If distance less than 500 millimeters, consider to be protect arm. K in this equation should be 2000 millimeter per second. But if safety distance higher than that, supposed to be 1060 millimeter per second. So and T is the time to take for the machine to stop after the right curtain is triggered. This value can find from the right curtain and the motor controller response time. In simple term, the right curtain must be positioned far enough away from the dangerous area. Okay. So and you can see the example in the pictures. At the top one, the one side require one pair of the light current, two handles in the closed area like this. And the T side access, you can minimize to use the reflections at the edge of the machine like this. Just only one pair transmitter here and receiver here. At the left one, you can use the reflections to like a mirror to reflect the right beam. But the S you should consider to calculate at the same way what I'm talking about. Okay, so and next the lock switch. So the safety interlock switch are essential device used on the safety door, fence, and guard to keep the worker safety by making sure these barriers are properly closed when needed. They prevent the machine from running when the doors or guard is open, reducing the leaks. Okay. Sometimes worker need to go to the dangerous area to perform the maintenance. In this case, the safety interlock switch on the door should be the open circuit. Okay, to reduce the leaks in the system. So and we also have the a locking type at the exterior for protection by stopping the machine from the running if the door opened to prevent unnecessary shutdown when the machine is safe to use. Today I will talk about the three type of the interlock switch. In the normal one, it work as the normal switch. When you open the door, it means the circuit should be opened. It will turn off some part of the schematic, some part of the machine functions, like a drive one. And if you include the locking type, that means when you would like to open the door, right? You can send the command to lock or unlock the door first, and then you can open the door in some schedulers function. For example, you know you would like to open the door when the robot moving, right? You send the command to the robot first. You are going to open the door to give them to park somewhere and remember the last position of the encoders, and then you open the door, right? That means you can do the recovery function and use the less time to recover the machine. So the key parameters to consider for the standard interlock switch. The first one is test mark. Ensure interlock switch meet the safety and quality standard. The second one is be here. Is the current and voltage ratings. It depends on your system design. Typical 24 is used for the safety circuit. Okay. And third one, C, is the number of contactors. So at least two normally close is required for the safety purpose. This helps to ensure the machine shut down properly if interlock is triggered, and also perform as the redundancy concept. And if it's possible, you should select does it have one normally open. You can monitor it's open or not. It will be good for your software functions because you know the status the door is open or not. You can handle in terms of software recovery. And last one is the type of interlock. The type of interlock you should depend on your applications. Okay. And I will uh talk more about the solenoid, the solenoid type or the locking type of interlock. It is a safety device that lock a door in the press is keep the door shut so no one can enter the dangerous area while the machine is still running. Even if someone try to open the gate, the solenoid lock will not release until the machine complete to stop. Okay. This type of lock is really important when there are moving part like rotating equipment that take time to stop. It helps to prevent by making no one can access. There are two type of locking safety in the lock switch. So the first one, sorry. So the first one we call the power to release. This lock start when the power is off. Okay. It uses a spring to keep the lock closed, and the model good for the slow stop machine like a big robot or spinning equipment that take time to stop. Another type is the power to lock. This type of lock when the power is off. The electrical to keep the lock closed. It good for the quick stop machine that's shut down immediately when the power is cut. So release the lock when power is off. Let's imagine when the like a power shut down, right? We cannot open the door. But if you use the type of the power to lock, it does mean it not there are no the power to energize to the coil. The door can open when the machine don't have the power. So and next the non-contactor safety in the lock switch. This type is perfect for the clean environment where dust or debris must be avoided, like a key room environment. Okay. So let's see how that work. Take a look at the right hand side. Here it shows how non-contact safety in the lock switch. It uses the magnetic functions. So look at the figure A here. When the magnet is far away from the sensor stay the open circuit. It means no signal is sent and machine stay off. And for the figure B here, when the sensor move into the working zone, I mean the side of the magnetic field, the circuit is closed, sending the signal that the door properly shut. Okay, allow the machine to operate the safety. So and last sensor is two-hand switch. So this system require operators to use both hands to activate the machine. So this ensures that the operator hand are safe away from the point of the operation during the setup, and it's often the machine operating cycle. You can see the redundancy sensing inside in the picture here for the safety purpose. You can see there are two controllers like this. Normally, it will check both of them is work properly or not. So any question? Yeah. And last one, I will talk about the robotics. Okay. So let me talk a bit about the robot operating areas. So when using the robot in the design, so you should understanding the operating areas is crucial for safety. There are two the major zone that we have to consider. The first zone we call the operating envelope. This is the normal working areas where the robots move as designed by the software process. It limited by the program instruction, okay? So the robots stay within the area during the regular operations. Another is restrictive envelope. This is the maximum possible area that the robot can reach. It defined by its physical limit, or we call hard stop. This zone becomes the important when there is the software error or system fault. So in terms of safety, focusing on if the robot moves beyond the operating envelope, it could hit an operators or dangerous nearby equipment. If there is insufficient guarding. So by understanding the protecting the restrictive envelope, we help to prevent accidents and equipment damage. So and next, how to protecting the restrictive envelope. To keep the people safe and prevent damage, the restrictive envelope of the robots must be properly guarded. This is the example. So the different kind of method. The first one, we use the interlock enclosures. It means the physical barrier like a cover that allow the robot restrictive area. It must be made from the like a strong material that it can withstand the force of the robot in the case of malfunctions. It means we use like a cover to all the machine, and it's strong enough when the robot hit to them. It cannot represent any leaks to other machine or people. And the second one, the light current. This is the non-physical safety barriers. That is the concept. As I mentioned earlier, is the infrared beam to detect something enter to the restrictive areas. So let's imagine if the human body or objects across to this beam, the system should immediately stop. Okay. So yeah, both method it help to ensure the robot stop safely when someone enter to like a danger zone, reduce the risks for the people and equipment. So and next I will talk about the safety step for robot maintenance in the restrictive envelope. So when let's think about when someone go to the area to maintenance to enter to the robot areas, they should following the procedure to maintenance the machine. Starting from the first one, we should limit in terms of robot speed when we access to maintenance machine. The robot must not exceed 250 millimeter per second. So most industrial robots have these safe features into the firmware. But if we don't have we buy some model, it don't have, we may consider to use the software to control. The speed should not be higher than this value when we use in this mode. The second one is detachment control. This is the special safety switch on the robot teaching pendant. It must be held in the middle positions where the operating the robot. Okay. And the third one is the EMO on pendant. The pendant must have the EMO like this. I think everyone familiar with this one. It's used to like a protect any leaks from the robot. Okay. And last one, the mode. The access mode should not be automatic mode when access in the machine into teaching machine, something like that. And last one, here is the step 2 recovery functions and the safety when we design the machine that require robot in the process. So for the restrictive envelope, we can limit it by hard stop. You see in the picture here, allow the robot based areas. Okay. We can use some screw or mechanical barriers added to control the working area of the robot. So, and the second one is I will talking about the recovery function again for the downtime. This is the crucial for minimize the downtime in the system. The controller that we use should be separate between the control and drive to reduce the recovery time. Yeah, that is the detail for the safety design today. So any questions so far? Are you there? Okay. And next I will give you the example for the safety design. And this part is gonna have in our examination as well. So today I will give you for this table example, and then I will send you this assignment. Okay, let's take a look, and next week we will go to the design this page again. And I will say this slide almost the same what we will will be your examination. Okay. It means if you don't have if you don't understand anything, you can ask me. You will get 15 points for free. Okay. Okay, let's go to I will code this one first. Let me share again. Okay. Can you see my screen now? Okay. We will design and select the protective device for, let's pretend to be it finished design from the design team and come out with this diagram. Okay. We will select the part and calculate the safety device. So this system requires two models, X and Y axis, and separate for the control and drive powers. And it's also required one RFID readers and digital I/O and one computer in the system. Okay. And the basics formula that we will use today is these three formulas. The first one is the power triangles. Second one is ohm triangle. And last one is the safety protective device. So I'm not sure have you used this one before. It's very easy concept. So for example, if P is the power, V is voltage, and I is current, right? So if you would like to know which parameter, you hide them. For example, you would like to know P, right? You hide P equal V time I. Or if you would like to know V, right? You hide V is P divided by I, something like that. Okay. And for the safety protective device, it is the lead current time with the safety factor at 25%. It means it's time to 1.25. Let's see in the table again, okay? And this one is the step how to calculate it. We will start from the calculate the consumption of the DC load first, and then select the power supply from the DC side and calculate the safety protective device and wiring side. This one is the DC part, and then we move to the AC part. We start to calculate the consumption of AC load, and then select the power supply to matching with the what the DC we design before, okay? And then go to select the safety protective device and wiring cable. And last one, we will calculate the main circuit breakers, ELCB, interlock contactors, and EMO contactor rate like this. Yeah. Let's jump to this one. I may switch to this one. Okay. Let's consider the part of DC first. Okay, if you see in this schematic, right, you can see the DC part is the downstream to the power supply. The first one is the computer here, right? It's connect to this power supply we call the safety power supply. And the second one is the downstream of this power supply we call the equipment power supply. It consists of the RFID reader and digital I/O here. Okay. Let's start from all of them first. Let's see. I make the table and separate from the DC and AC component like this. And I will add the component here. In the examination, you just calculate in the orange table. Let's start it again, okay? Starting from the computer part number PP, the part number is PPC T120, right? Go to look at the data sheet here. Look at the computer first, okay? In this computer, look at the input voltage and power consumption. Usually the data sheets will tell you voltage, current, or power. Sometimes it tell you just only voltage or current. You can calculate back to powers. Or sometimes it tell you voltage or power like this. You calculate back the current. Let's see this example. The voltage input is between 12 to 30 volt DC, right? And the power assumption, in worst case scenario, it has to the power we consider to use the maximum power that it used for our calculations. This is supposed to be 36 watt. Okay, go back to the table. The computer is input voltage is 24, right? And power consumption is 36. We calculate back. The power is power divided by volt. Is come out with the current, right? So the current multiplied by safety factor at 25% is become to 1.875 here. And the circuit breaker, you can select from the closest value. Let me remove this one. The closest value from the standard circuit breaker rate here. The closest value from 1.8 is it's supposed to be 2, right? The circuit breaker that you use in your schematic, it should be 2 amperes like this. And the last one is the Y side. Let's remember this value, or you use this value to the table here. Let's consider at the temperatures at 75 degrees Celsius. So it will tell you the Y side and the lead current that the Y can handle. The example is we would like to use the cable that can handle over 2 ampere, right? The cable sizing that we will use is 24 AWG, like this. Y side 24 AWG. Any question? Okay. Let's take a look at next component. So the RFID reader, right? Go to the data sheet first. RFID here. Okay. Look at the power consumption in this table. It's just 24 volt DC, right? And the maximum the power consumption is 15 watt. We will use this one for this value for calculation. Go back to table. The voltage is 24, right? The consumption supposed to be 15 watt. And when we calculate back in the same way, multiply by 24, come out with this value, right? And when it's timed by 25% safety factor, it is this value, right? We choose the closest circuit breaker rate from standard one. It has 0.5 and 1 ampere like this. For me, I consider 1 ampere to use. Okay. And we will use this value to select the Y side again. Go to the cable side. The maximum, we look at 25 degrees Celsius table here. And should The maximum holding current is 1 ampere like this. The cable sizing support to be 26 AWG. Any questions so far? Okay. And next, we have finished the RFID, right? And next is digital I/O. But for the digital I/O, I assume the input current is 8 ampere, right? And after we calculate back, the power is 192 watt. After is time with 25% safety factor is supposed to be 10 ampere, right? The closest value, the standard is 10 as well. Okay. We will use 10 ampere to calculate back to the Y side. Go to the table. The maximum at 10 should be this cable. The Y side is supposed to be 16 AWG. Yeah, that's it for the DC side. Any questions so far? So and then we know, right? The safety power supply rate from the design it requires at least 1.875 ampere to sourcing, and for the equipment power supply need at least 10.8 amp to sourcing. Let's go to select the power supply, and in data sheet I give your three side of the power supply. The first one is can sort current up to 2.1 ampere like this. The second one is 5 ampere, and the last one, oh, 4 type, and the third one is 10, and last one is 20. We choose the closest one as the system required. Okay, go back to this. One require at least 1.8, right? Another one is require at least 10. Okay. The first one supposed to be ML 50.10. And other is 10 point, 10 point what? 10.78 at least. I think 10 amp should be enough because of the value that we calculate is multiplied by factor 25%. It does mean the railroad it should not reach to this one. Thus, we can consider to use 10 ampere for power supply. It should be enough. We can like a save for the component that we will use in terms of cost and sizing. If you use the 10 ampere power supply compared to 20 ampere power supply, the cost of 20 ampere power supply is should be 2 times of 10 amperes. Okay. I will use this model CP10. Okay, that's it. Let's go to the data sheet again for each of them. The first one, the output is this one, right? We would like to calculate the safety component for the input. The input voltage AC between 100 to 240 volt, but we will use 240 for calculations. And the input current is here. If we use 100, right? The input current should be 1.09. And if we use 240, the current consumption should be 0.6 amp. Okay. That means we will use 0.6 for calculation. Okay. It calculates back to power consumption and the current here. And then we choose the same way what DC done before. 0.75. The closest is I select one for the circuit breakers and use the same cable sizing. And we can copy for the DC one. Okay. And the output current is this is following by this part number. Let's go to this again. The power, the current output that can sort is this one, 2.5 ampere here. Output current 2.5. Yeah. That is convert when we convert to the power is around 50 watt here. Any question? Okay, let's go to next is this one, right? I think I calculated the wrong table. 0.44. This one is 4.6 here. This one's supposed to be this 0 and 24. 5 here. This one is circuit breaker 0.5 should be enough. 0.58. 0.5, 0.5, 0.5. 30 AWG. Okay, that's it. So any questions for the power supply selection? Okay, and next move to the motor controller. So we have the X stage and Y stage. That is separate between the motor controller and driver, right? So we will use the same part numbers, HPE20. Okay, let's go to the data sheet first. Here we go. Okay, for the model supply, it used the voltage between this one, right? And the current, let's consider at the maximum for the worst case analysis. This model, right? HPE20, it used 10 MIMS. And for the controller part and for the control part, the maximum input current is 1 amp like this. Okay. Go back to here. Control it 1. And drive it 10. Okay. That is come out with the current time with 25% safety factors. And we go to select.เดี๋ยวนะ อ๋อโอเคตอนนี้เห็นหน้าจอยังครับเห็นหน้าที่เป็น Excel ไหมครับเมื่อกี้ที่พี่พูดมาไม่เห็น Excel เลยใช่ป่ะเอาใหม่ไหมโอเคโอเคตอนนี้เห็น PowerPoint ด้วยไหมถ้าพี่เอาออกเงี้ยโอเคโอเค let's do again โอเค let's start again okay uh let's start from the DC part. As I mentioned, we have the downstream from this equipment power supply is the RFID and digital I/O, right? And the downstream of the safety power supply is the computers. We will start from the computer first. Okay. Go to data sheet of the computer. It uses the voltage between 12 to 30 volt and the power consumption we consider at worst case is 36 watt, right? Thirty-six watt here, we calculate back to the current is power divided by volt. It here, right? And then we time with the 25% of safety factors. We will use this value from these standard circuit breakers. This value is you can buy in the market. So I mean the manufacturing. Okay. They don't have like a specific number like this. We choose uh the closest one to this value. This one supposed to be 2 ampere like this. And then we will use this value to find the cable side, the Y side. Go back to the cable side. Okay. Uh, this table we consider at 75 degrees Celsius, right? We will see, you can see this the holding current that this cable can hold at 75 degrees Celsius. It is 24 AWG here. You put them to the cable side AWG. Is it clear for you? So and next we will find the circuit breaker for IO and this RFID. I think someone asked me. Nope. Okay, go to the RFID datasheet first. RFID. This one, the power consumption you can see in the datasheet. It uses 24 volt DCs and 15 watt for the power consumption. Go back to the table here. We do the same way to calculate. It's come out with the input current and then we multiply by it 75%. Okay. And then the circuit breaker is supposed to be 1 ampere here. We use this one to select the cable side again. To be, yeah, 26 AWG. 26 AWG. Okay. And last one for the IO, I put this one. I assume it's just the current at ampere here, and after it calculate back, it will be here. It will be time with 25 safety factors. The circuit breaker with the standard circuit breaker rating here is 10. And then use this one to select the Y side again. Sorry. 10, right? 10, 10, 10. 16 AWG. Yeah, that's it. After that, we will get the power supply rate and equipment power supply rate here. The power supply that we will select, it should be equal or higher than this value. Okay. The first one, the safety power supply rate. We go to the data sheet again. I have 4 model for the power supply for your selection. The first one, the maximum current output is 2.1 amp. The second one, 5 amp. Third one, 10 amp. The fourth one is 20 amp. From these two value, I select 1.2 amp for safety power supply, and I select 10 amp for equipment power supply, like this. Okay, you put the part number here, and then go to calculate the input and select circuit breaker Y side and output current. You can push following the data sheet again, 2.1 and 10 amp, like this. Okay, so go back to the data sheet from the first power supply. This one, right? So consider add the AC input current and input voltage. It is switching that can use the voltage between 100 to 240 volt. That means you choose one of the input current here. If we use 240 volt, 0.005 amp consider to use for the calculation. We do the same thing with this model, right? Supposed to be 0.6 amp. 0.6. Okay. That is come out with the multiply by 75% factor. For this one, the closer this is 0.5, right? And other is 1 ampere, like this. Okay. We use this value to select Y side again. This one I can copy from this. And 0.5 is 0.5 is 30. Yeah. Okay. TAWG. And then go to the motor controller and drive. Okay. We use HPE20. HPE20. This model. You can see it's separate between the motor supply and control supply. For the motor supply, the maximum the current is 10 amps, and the maximum for control power supply 1 amp here. We will use this one for the calculation. Controller amp, no, control 1 ampere, and this one is 10. Yeah, that's it. And then select the the circuit breakers that's closest to this value. Okay, the first one 1.25, right? We don't have 1.5 or the closest one, we consider to use 1 ampere as well. If you look at this one 1.25, right? The closest is supposed to be 1, but you choose consider at the normal current that is used. This one is 1, right? The circuit breaker that you use it should not lower than is the input current. Okay. 1 ampere is enough to use. Let's consider like this. If you use the if you use the higher value, it means it hard to trip, right? You need a lot of current to trip it. It means you use the small values of the breaker is safer. Okay. And then use the Y side like this. It's the same AWG number, right? And last one, 12.5. The closest is between 10 to 15, right? As I mentioned before, I use 10 ampere should be enough because of if you compare with the normal current, it should be enough to control this one. Okay. You can use the 16 AWG for this one. And this one is come out with the MLCB and ECB rating. Okay. You choose the circuit breaker for the main circuit breaker and aggregate circuit breaker for control entire machine from these values. If you see this one, the closest one is should be 32. Okay, 32 for ampere for main circuit breakers and 32 for ELCB. Okay. And then use this value for the cable sizing. Go to the table again. The the sorry, go back to this value. We use the rating current of the circuit breaker, this one, right? But if consider in the normal value is 28.8, this is over spec. And when you select the Y, you choose select the closest value and it should be this one. It should be 30 ampere, right? That one is 10 AWG. And for the interlock and EMO ratings, okay, this one is the calculate value. You can use 25 ampere for this one. And for the EMO contactor rate, it should be equal or higher than this one. The standard, it should be 30. This. So I think that's all. Any questions? Okay, I think that's all for today. I will send you this Excel, and I think I can share you for this example slide. Okay, I will send this one to Ajahn Phum. Okay. So any questions so far? And Ajahn Jack told me next week you have some activity, right? Most of you cannot join these sections. We can move to art. I'm not sure what day you prefer. Let's talk with your friend first, and then you can chat me in the group with with day you prefer, with time you most of you can join the training. Okay, if not, that's all for today. See you in next class again. I will talk about this calculations, the safety factor again. Okay. Yeah, that's all. Bye. See you.